Good afternoon, everyone. Can you hear me? Yeah. So thanks for joining our session about building a national AI and big data cloud with SUSE's software-defined infrastructure. So my name is Derek. I'm the senior cloud technologist at SUSE. So today I'm very honored to invite our partner who has been getting involved a lot on helping his country to build this cloud platform. So he's coming from OpenStack. Please give him a round of applause to here at SUSECON to share this story with every of us. So what today's agenda is about, we will talk about this customer, NARL. They built a cloud platform for their region about a cloud project. So that is building it for the use of AI and big data analysis. And then we will go through about how this can be used for this platform and our implementation journey, how SUSE work together with our partner to make this happen. So this is what it's all about in the coming 60 minutes. So before I go deeper, let me introduce our partner. So my name is Derek. So I have been helping the customers at SUSE to adopt the software-defined infrastructure to enable their cloud journey for customers to make them successful. So Justin, let me pass the time to you, and you can introduce more about yourself and your company.
Okay. Good afternoon, everyone. I'm Justin Gao, and I have 10 years experience in cloud solutions. And I joined OpenStack from 2015. OpenStack is Taiwan's leading open source solution provider and a consulting company. And we have much experience in deploying OpenStack, Ceph, and Kubernetes. There are about 40 engineers at OpenStack, and and some of them are certified OpenStack administrator and certified Kubernetes administrator. Because of these top-notch people, OpenStack became OpenStack Gold member since 2015. And our VP, Joseph, became OpenStack Foundation Board Director since 2017. In the same years, we became CNCF Silver members and Kubernetes certified solution provider. So next, last year we were happy to work with SUSE to win this big project and deliver the AI cloud in Taiwan. So next, that's Derek.
Thank you, Justin. Thank you. So as you can see here, OpenStack has been very committed to the open source community. They also share the same vision as SUSE does to help the customer to adopt the open source technologies to enable their success. So let me now turn into talking about what we have done in the last year to enable the AI-based cloud project. So for this customer who is going to build this AI cloud project, they are a government-funded organization. Their name is called National Applied Research Lab, NARL. They are founded since 1991 in Taiwan, and they serve the Taiwan region for all the high-tech computing platform for the university or the academic area or even some private organizations. So what they are doing is they go through this organization called NCHC, National Center for High Performance Computing, NCHC, which is the subsidiary of NARL, to build a platform like a large computing and networking platform for the organization in Taiwan to consume. Basically, they use this platform as a cloud service for storage, and then also for big data analysis, or even doing some scientific and engineering simulation to achieve their research work. This is their background. And now, as they can see in the recent years of development of AI technology, machine learning, IoT, they want to tap on all these advances of the technologies to make it beneficial to their industrial development and to promote all this technology for their daily uses. And so the government, since quite some years back, they approved the funding to enable NCHC to build this AI cloud platform with the open infrastructure principles to be able to have all the facilities and all the library or the development platform that the research center can use to develop and build more applications around it. So their idea is to enable the AI technology development by the other researchers or the private organizations. And also at the same time, they want to develop more tech talents in Taiwan to be able to tap on all these new technologies to help to boost the productivity for this region. This is the overall scale of the project that they are thinking about in the initial stage. So they want to tap on the GPU. They are talking about 2,000 units of the GPU to build the initial AI cloud, which is making up to about 9 petabytes of flops. And then they also want to, at the same time, with the intelligence that they build, they also want to tap on the data, the big data cloud. So they are talking about using about 250 cloud nodes to build this big data analytics platform. And in terms of the storage scale, they try to build it into 50 petabytes in this overall project. They have the computing capacity, analytics for big data, and a big volume of the storage for this scale of the project. What they plan to do is they want to, within 4 years, they will invest in about 1.6 billion of US dollars to build this platform to enable all the beneficiaries like researchers can make use of this platform when it's ready. And the core team to build it is around 80 people. So they try to build it within a year, and then they try to build this platform with this core team to build up the whole project in a short period of time to go production. So here's the core team member here. As you can see, they appointed Taiwan Mobile company to build the data center. And then they invited the hardware vendor, like the local Taiwanese hardware vendor, Asus, Qantas, to lead the building for the infrastructure. And they introduced NVIDIA, IBM, Menelux, all the advanced technologies to build up the hardware to make use of the AI. And then you can see that SUSE has been partnering with Asus and also OpenStack to help them to build the software-defined infrastructure on top of this hardware to enable it. So before I move further, let me play a short video clip to wrap up the whole project background for you. But you will be speaking in Mandarin. What I have done is we put back the English title here for you to enjoy the video. Let's go.
AI 人工智慧科技应用浪潮席卷全球，从零售、金融服务、生技医疗、自动驾驶、机器人、智慧城市等 ，AI 将改变人类生活。财团法人国家实验研究院国家高速网络与计算中心研发新一代 AI 高速运算平台，命名为台湾山2，结合顶尖产业。台湾大哥大、广达电脑、华硕电脑共同组成台湾人工智慧 A Team， 由国网中心规划国家 AI 平台发展策略，并结合3家厂商之所长，整合网络、软硬体开发及运算系统整合， 台湾大哥大拥有东亚第一高阶云端机房建制经验，以国际最高标准完成台湾山2基础建设。台湾山2具备4大领先优势：水冷式机柜独立回路设计，采用板式热交换器，设备元件1+1备源设计，电力配置采双电源回路设计，搭配高速光纤网路，确保高速运算主机运作稳定及资料传输安全快速。同时导入 busway 电力汇流排设计与光纤专用导槽设计。资料备份方面，引进 IBM 高速多功能整合式资料仓储备份设备，多台磁碟主机可同时读取庞大数量资料储存与备份。广达电脑负责平台核心设备，水冷式 AI 高速运算主机建制。AI 高速运算主机内含 GPU、运算伺服器等高端科技设备，且主机采水冷机制，搭配机柜式空调 ，PUE 值最低可达1.2，达成绿能节能目标。最后由华硕电脑构建专业云端主机与 AI 云端平台，让 AI 高速云端主机能发挥最大运算效能。AI 云端平台提供完整的 AI 工具，强大计算力，藉由统一的自助式入口网站，让平台具备完整软体 API 可再开发应用。台湾山2是由国网与台湾大哥大、广达电脑、华硕电脑3大顶尖企业跨集团、跨领域合作成功案例。建制期间，团队藉由及时沟通讨论，充分掌握问题状况，以最有效率的方式，依时完成各项作业进度。台湾山2共运用2016个 NVIDIA 新一代 GPU， 总运算能力达9 PFLOPS， 总储存量更高达10 PB， 在全球超级电脑中排名第20。是台湾首度进入超级电脑排名前20大。国网中心 AI 云端平台建制，是台湾领先全球 AI 科技的重要基石，让产官学界借由台湾山2完成产业 AI 化、AI 产业化，并建构大数据资料中心，应用于物联网、FinTech、智慧城市、智慧医疗等产业领域。台湾山2让台湾产业强化既有优势，成为尖端智慧国家，启动台湾 AI 云端经济新里程。国网 AI 开创 AI 新时代。
Okay. So hopefully this video wraps up the background of this project, and you can see the scale of the infrastructure that the government units has put onto this data center to enable the AI initiative for their society. So with what they're built so far, you can see that here, compared to the past high-performance computing that they have done, this has been achieved to a new high here. It's now ranking as the top 20 supercomputing in the world. And here, they achieved the performance of having 9 petaflops here. So to let you imagine what was meant by 9 petaflops, you can imagine if you have an iPhone 10 on your hand, and then you collect them together, making it up to 8 million units of it, that will be the equivalent computing capacity that you can get from this data center. So that is a very powerful data center that they have built. And to be more detailed, and then you can see that here, this is the scale of the hardware that they put. Say like about 250 computing nodes in here, and adding up to total together now 1,000 CPU core, and then with a total memory about 200 terabytes. And then each unit, you can see that they also equipped with the NVIDIA GPU card here. So with 8 cards per each hardware. So each hardware is very high power, but it doesn't mean that it will work alone. You can see that they also use the open source software like Slurm for high performance computing unit, which Justin will go into details later. Kubernetes, Ceph, OpenStack, they will use all of this open source infrastructure software to empower this hardware investment that they have done to build this AI platform. And once they lay out the software-defined infrastructure, they can run any kind of the AI framework that their developers need to run on to enable their creative work for AI application. This is a very high-level design of the AI cloud platform. As you can see here, they invest at least the GPU cluster to do the AI computing, and then they also have the CPU cluster to run the regular computing capacity. And then they also build up the data center with the storage to connect the two with a high latency, high bandwidth network. And on top of it, they lay out all the platform that they need to use to build up their APIs for medical development, energy, environment development, smart city development, and so on, blockchains. You can see that this is the idea how they put all this together into a working AI cloud. So let me pass the time to Justin to explain to us how this AI cloud was built and worked. Yeah, it's up to you. Thanks, okay. Justin. Thank you.
Thank you. Okay, let me take a deep breath. Oops. This is the software stack we use to build the AI cloud. So let me introduce you from bottom to the top. For the network, I just point. We not only use Ethernet network, but we also use InfiniBand in the HPC cluster to accelerate the the computing. And for the storage, we use SAS5 to provide various kind of storage in addition to the GPFS. The GPFS works as a high-performance file system in the traditional HPC cluster. So the SES5 provides a balance for the VMs, and it also provides object storage for the users to upload their file. In this case, we also introduce NFS Ganesha, which can export the S3 bucket to containers by NFS. So in the next slide, I will introduce the data flow later. So roughly, there are two kinds of server in AI cloud. One is CPU node, the other is GPU node. GPU node is a server with 8 NVIDIA cards in that. So the GPU node is shared by two clusters. One is Kubernetes, and the other is the traditional HPC cluster. For traditional HPC cluster, we use Slurm to schedule a job and use Singularity container to run the Docker image. For the CPU nodes, they compose the SUSE OpenStack cloud computing node. And for the user, instead of using the Kubernetes cluster, they can also deploy their own private Kubernetes cluster in the VMs. So they have a private environment to run their containers. And since the NVIDIA have provided a comprehensive category of Docker image, so we based on this image and customize some Docker image to run in this this AI cloud. So on top of these three platforms, we have an orchestrator to provide a unified interface for the upper level application to deploy resource in different kind of platform. And the API gateway is the most important interface in the whole cloud, because the NAR imagine that other people will write their own application to access these different kind of resource. So we provide the application programming interface for the users. And in this case, we implement just a user portal and the admin portal for humans to access and operate the whole system. So from the user point of view, they can use not only VMs containers, but they can also run a traditional AI HPC job in the whole system. Okay. So I guess all of you have a rough idea of the architecture of the AI cloud. So next, let me explain some user scenario. The NARL imagine that the user will go through these 6 steps to use the AI cloud. The first one is the user will upload a lot of data into the cloud by using S3 protocol. Because the S3 protocol is the most popular object storage protocol right now. So users already know it, and they can use it very easy. After they upload the data to the cloud, the user will have to do some data cleaning and extraction, some features from the raw data. And then they will choose some pre-trained model from NARL and do some fine-tune and optimization. After they got a satisfied model, they can deploy their application, and so that the end user will use their service. And after building such a big system, we want to find some data to test our system and go through these 6 steps. So after short research, we find that in Taiwan, Taiwan is a small island. The length of Taiwan is about 250 miles from north to south. And there are 2 highways in Taiwan. And there are over 1,500 video cameras in these 2 highways. So we can utilize this data to predict and to show the traffic flow on these 2 highways. So we build a application to go through this process. So first, we start some VMs. Sorry, I'm not. Go back. Up. Oh, sorry. We start some VMs, and this VM collects video stream from those cameras and some CSV file. The CSV file has write a current speed of traffic flow, so that we can verify that if our prediction is correct or not. These VMs will store the raw data in the object storage, and then pass to the Hadoop cluster. And there are several Hadoop clusters. They are doing the batch job. Once they got a bunch of raw image from the object storage, they will transfer that into they will resize the image and make it a grayscale, and then it will store it back into the object storage. Then we will start some jobs, which could be Kubernetes jobs or Singularity jobs. These jobs will read data from the object storage and then store in the GPFS and it will train the model. After they got a final result, they will store it back to the object storage. So the inference VM can read the model and the raw data from the object storage and do some inference and show the result to the customer. Okay, this is the idea of what we got from the user application. So next.
Oh. Thank you, Justin, for explaining one of the use cases on how to analyze the video that you collected from the highway and to do some prediction on the traffic flow and do an even distribution of the traffic for the whole country on the highway. So let me also share with you about our implementation journey. So building this cloud platform is obviously complicated, and no single vendor can simply do everything alone by themselves. So SUSE has been partnering with our other team players, the core team, to build this AI cloud. So let me go specifically on the SUSE OpenStack component that Justin has just earlier mentioned. So the scale of the deployment that we have made is about over 200 compute nodes over there, which is quite a big size for the country at there. And there's no single vendor has such experience to build this scale of the cloud. And so you can see here they use the network bandwidth IB 25 gig here, and the backend is connected to the SUSE Enterprise storage with a SAP-based storage here. And they try to use all these key features in OpenStack to enable their AI cloud platform. Specifically, on the network side, they use firewall as a service, load balance as a service to coordinate all these jobs to be running in a multi-tenancy environment. And then they keep monitoring the environment on real-time basis with the Monasker module provided by the SUSE OpenStack Cloud. They often also use the heat orchestration to provision new jobs onto the OpenStack Cloud for automation and to run all the automated jobs, just what Justin has mentioned before. And you also leverage the GPU capacity to run some AI applications on top of this OpenStack Cloud. What I want to highlight here is that the team that they make use of the Cloud Lifecycle Manager provided by the SUSE OpenStack Cloud. It has some pre-built template to build this large-scale OpenStack Cloud quickly to shorten their implementation time. So they leverage on all this pre-configured input model to help to build out. And likewise, in terms of the scale of the SUSE Enterprise storage, you can see that they try to build it with the reference architecture that we provided. And the raw data that they end up build up is about 30 petabytes as an object storage that they need to put in all the videos into this big storage. And also the block storage with 3 petabytes that is used by the SUSE OpenStack Cloud by those VM images. So this has been also implemented with the reference architecture that we provided to our partners, and is all building 2 very reliable Ceph clusters for them to be part of their AI cloud platform. But it doesn't mean that we don't have any challenges to build this kind of scale of the AI cloud. Let me have a quick interview with Justin about the challenges that we got so far. Let me highlight one of them. So what is the most challenging part in designing the AI cloud, in your opinion?
Okay, because building an AI cloud is a new domain in our country, so we have no experience of it. So when the project started, requirements always change. So in this situation, we need an open architecture that can quickly change the component to fit this situation.
Thank you. So in that case, why do you choose SUSE OpenStack Cloud and SUSE Enterprise Storage as part of this AI cloud platform?
I really appreciate that SUSE choose the open source project to build their product and even enhance it. And we have so many experience to deploy OpenStack 7 in Taiwan. And SUSE OpenStack Cloud and SES is the most stable than the other distribution. So that's why we choose SUSE. And in the other hand, because this is a 5 years project, the scale will expand in the future. So we also need a cost-effective solution in this case.
Okay, thanks. Thanks for your compliments and thanks for your experience sharing. So basically, the implementation challenges, I think, in the beginning, is more about designing the components, how to put all this together. The team has been spending a lot of time to design what kind of specific components that they should put together into this AI cloud platform. And SUSE has been participating in that process. So, and we try to bring up the idea of using the open source way, the open way to do it. And the benefits is that they realize the open architecture can really adapt the changes that they made during the discovery journey, that they are discovering how to build it in the optimal way for the AI cloud. So this is the key challenges that they have, and thanks for sharing. And then on the other side, the customer, the NCHC, they also share with us why do they want to choose SUSE. One of the best things, of course, is that they need to provide the AI cloud as a service to their end customers, like the researchers, other universities, or some private organizations. So they need to maintain a service level agreement with these customers. And so they need to have an enterprise-grade support of the platform that they own, and then to make sure it's reliable, and in case there's a problem, they can provide the service to fix the problem quickly. And so SUSE also has the professional service that we can offer to optimize the environment, to optimize the investment that they made at there. And so this is one of the key reasons why they choose a commercial vendor for that. And then at SUSE, we also have the previous track record with NCHC. Before they build this AI cloud, actually, we also have developed a big data platform, analysis platform, with OpenStack for them before. And the platform runs very well so far, and so we build a trust with them. Also, we have a strong partnership with the local service integrators in Taiwan, like OpenStack, and so they trust the partnership together can help them to realize their platform more quickly. And one of the interesting things is that they find us, compared with the others, are more committed to the OpenStack community. For example, one of our employee, Alan Clark, he has been the chairman of the OpenStack Foundations for more than 7 years, driving the direction and vision of how this OpenStack project should go to benefit the entire industries. So with all this, that's why they choose SUSE to be part of their team to help them to build this AI cloud for their society. So we continue to have a regular executive support from SUSE and for our partners. For example, last month, our VP, Andy, has been made a visit to check the progress of the projects, the build out, and so on, to make sure everything is going smooth. And in case the customer needs to gain support from us, we can help them. And here you can see that this is the VP of OpenStack and Joseph and Andy. And then you can see from ASUS, we have the GM. We always have a regular meeting to make sure the customer's project would be on track and doing it on time and within budget. So we've been doing regular visits to ensure they have a successful implementation from there. So that's the end of our presentation. Any questions from the floor that you want to ask? If there's any other questions, then thank you very much for attending our session. I appreciate it. Thank you.